Okay, maybe let's talk about a couple things here, and then you can finish some of the rest of this here. This first one, as I said, you don't even need logarithms to solve or to find the value because you sub it in. As long as you can evaluate it on your calculator, 25 e to the power of 0.022 times 20. You need brackets around that because otherwise it interprets it with the wrong. Well, it interprets it with the order of operations, even though you didn't intend that. So you should get about 38.8 million. All right. The only difference here, I know, and again, we don't have necessarily the time to see this, but 38.8 million here. Actually, 38.8, well, this is Math 12, so the rule in Math 12 is don't actually think about what makes sense to give as an answer. Just do 2 decimal places unless it says otherwise. Like in science courses, they actually have you think about what's reasonable to give as the accuracy of an answer. Math 12, they don't want you to think. They just want you to follow rules and say 2 decimal places. Like this is one beef I've always had with this. Like provincial exams, one time I was marking, and they forced us to take marks off if people didn't give an answer accurate to 2 decimals, even though it was a ridiculous, like it was predict how many years it's going to take for the population to reach 10 million. And it was like 93 years or 93 weeks or something like that. And somebody put, oh no, it was 92.88. And somebody said, roughly 93 weeks. Because it's not going to be that anyways. Like if you go 20, when you measure when it's exactly 25 million, first of all, you couldn't measure it to exactly 25 million. And it's not going to be 38.82 million 20 years from now. It's a prediction, right? In reality, this would be a prediction. But in Math 12, we got to do 2 decimals. So put that down if you can. Like in reality, if we're only measuring a couple digits here, you can't go all those digits here. But whatever. Anyways, that's the number you should get to be able to evaluate that. The natural logarithm key, again, it's the inverse of that. You know, this natural logarithm of 3, base e was 2.71 something, so this should actually be just a little bit more than 1.09 or something or other, I don't know, something like that. You can think about it's going to be hard, obviously, to predict what they are without a calculator. So, no, this is with a calculator. This one without a calculator, the reason I put that in there is because I want you to realize ln of e is the same as if I said, what's log of 10, right? Log base 10 of 10, or 10 to the log x. These are inverses, right? 10 to the power of log of something, those are inverses, so what would that be? 10 to the log x? That would be just what? That would be x, right? Well, if I put a 1 there. What is log of 10 to the x? Log of 10 to the x is just x. These are inverses, right? Log of 10 to the power of something. If we do log base 2 of 2 to the power of n, what is it? Log base 2 to the power of, those are inverses, right? And so if you have something like ln of e to the power of something, it's just, this is like a 1 here, right? That's 1. Natural logarithm of e to the 4th. This is like if it says log base 10 of 10 to the 4th. Or log base 2 of 2 to the 4th. If you have it written as a power of the base you want, e is a base, that base. This is 4, right? You can check it on your calculator to see if you want. E to the ln of 37, e to the natural log of 37, those are inverses. And other things to note here, this follows all the logarithm laws you know before. This should be just 37, right? Ln of 1 is like if it says log of 1, or log base 2 of 1, log base 7 of 1. What's the log of 1? It's 0, right? Because it's 2, like this is 2 to the 0, this is 7 to the 0, this is 10 to the 0, right? 1 is always something to the 0. The only other thing to notice here is that I put this statement in here just to remind you that all the logarithm laws, this apply. They apply to this logarithm just like any others. What's log of A plus log of B equal to? Log of A times B, right? So if I said ln of A plus ln of B, what's that going to be equal to? Ln of AB. All these rules work with any base logarithm, right? Log base 2 of A plus log base 2 of B. You've been using this rule all along here, right? Log base 2 of AB. All those rules work with any base you want. Well, where'd that go? There it went. Okay, that's really good. If you're solving an equation with E, remember, the goal is, I don't want you to freak out when you see the E. I totally don't understand the E stuff. You just have to realize that's the same as a grade 8 saying, I don't get this pi stuff, right? This thing's with pi in it. It's a number. It's put it on the calculator and work it out. You can solve, if you happen to know something about base E and natural logarithms, you can solve it that way. It's probably easier that way. If you don't know, you can still solve it with base 10 logarithms. Doesn't matter. Okay? And then the last question here is solving for this variable, solving for the exponent. You should be able to do that with or without natural logarithms. You can make your choice, whatever you like. I do want you to notice, I mean it's not terribly important, but if you notice, the only difference in here between what we've done with using other modeling here is this function looks like P equals 28 e to the 0.03 times t. If we had something at 28 million and growing at 3%, we would model it as 28 times 1.03 to the power of t. The only difference here is instead of 1.03 to the power of t, we're using e to the 0.03. Right? That's the only difference. That function says 28 e to the 0.03 times t. If you look at your calculator, e to the 0.03 is roughly the same as 1.03. They're almost the same. It's just a slight difference in modeling here because of thinking about whether it's continuous or not. Come on. If you do e to the power of 0.03 gives you roughly 1.03. They're almost the same. The only difference is that difference because of thinking about whether it's growing continuously or not. Again, it'd be good if we had time to think of this in terms of how it relates to higher level courses, but can you work on finishing that page? So task number 1 is finish this page. Task number 2, work on some practice for everything up to this. After lunch, we're going to do that quiz on the graphing stuff, section 7 and 8. Don't let that mean that you're going to suddenly say, okay, I'm not working on this. Don't worry about it, okay? If you do finish this stuff and you're happy with how you're feeling about the practice and everything, you can work on your assignment. After lunch, we're going to work on quiz, mark the quiz, work on our assignment. Let me show you right now, actually, something else. Actually, one other thing I wanted to show you. If you happen to have a TI-84, depending on how recently you bought it, or even if you bought it a while ago and it doesn't have this, you could add it. This is, these calculators are 99% the same, but this happens to be one thing that you can do on here. If you've updated it to the latest operating system, it's strange to talk about operating system for a calculator, but and if you want, you can. It's on this computer here. I have it. You can update it. It has some added features when you go to this menu. If you go down, there is something that says, whoops, I'll go back from the bottom there, it's quicker. It says a couple things here. It says summation, which we'll use later in the year, and this log base. It's just, it allows you to do things like log base 2 of 32. Whoops. Especially if you know how to enter it on calculator. So if you've updated it to the latest operating system, or if maybe you bought it recently enough that it already has that, it evaluates that for you. I don't want you to feel left out if you have this calculator. It's really not that big a deal, because if you wanted to evaluate log base 2 of 32, you can use base 10. Log base 2 of log of 32 divided by log of 2. That's why it hasn't been on the calculator up till now. The reason this is on here is not because you need it. It's because it's a selling feature, and people go, "Oh, cool! You can evaluate other logarithms. I'm going to buy their calculator." That's why it's there, right? Because they're in the business of selling calculators. You don't need it. You can do this. It's not hard, right? That's the same thing. In fact, if you want it to be shorter on the screen, you could just do this, right? It doesn't matter what base you're using. You can use natural logarithms if you want. In any base you try, right? Those are the only two bases on this calculator because those are the only ones you need. But if that's, I agree, this is kind of cool that it has that on there. And the other one actually in that list was even cooler. And while I'm trying to, it sounds like I'm doing a commercial for their calculator here, but while I'm doing a commercial for their calculator, the other thing that it adds is, it adds the fact that you can do fractions like this, right? Like 2 plus 3 times 5 divided by 4 to the power of 5 minus 7. Oops, I don't want that in the exponent. It writes it like this. Okay, it writes it like a vertical fraction. Again, it's not something to be terribly, and it gives you your answer as a fraction. You can do all of those things on here, but if you happen to like the looks of that, you can change it. Because you can go 2 plus 3 times 5, bracket. You just have to keep track of your brackets. 4 to the power of, it doesn't show it as the little number like that, minus 7, right? And as long as you've entered it correctly, you get the same thing, except you get it as a decimal, but you can always go to math on either of them and change it to a fraction, and it'll show you the fraction like that, okay? I know it looks cool like this. One of my students last year discovered this. He said, I was on the Texas Instruments website because I had to fix something on my calculator, and I updated it, and look, it does all this cool stuff now, and they were all excited. And I have to admit, it is kind of cool, but it shows, it's called math print. It just shows it the way it's written on the page, which is helpful in some situations, right? 5 to the 6th, the number's small like that, rather than doing this, 5 to the 6th. Same stuff, though. Okay? Oh, now you feel bad about your calculator? It's not, you just have to say, I'm smart enough to realize it doesn't matter, right? This is the way of the world now. As soon as you have something better comes along. The world changes so fast, except for Texas Instruments calculators. It took them 20 years to do that, but, right? This is basically, other than that one feature, this is the same calculator in a fancier box, with more RAM to store more programs. Big deal, right? But